Welcome back, ladies and gentlemen. What we are having here is part 3 of our topic, which is accessing memory. Please subscribe, share, like, and click the notification button so that you get notified, or you get a notification whenever I upload a new video. Right, so here we are proceeding with our example number 1, which is this one, accessing memory example. Right, so what is happening is this: we are loading quad 1 into a memory location which is 1234. So our offset here is 1234. If you are to calculate a physical address, we say 1234 plus in brackets, let me just type it here as a comment. If we are to calculate the physical address, we say our offset is equal to 1234 h, and if we are given that our data segment value is equals to 1000, now we need to say our physical address. It now becomes 1000 times 10. So this is the starting address of our segment. So we add that to our offset 1234 h. We get the physical address, right? But here we want to observe what is actually happening. We have loaded this value to this location. Now we want to observe what is happening. We want to get the value that we have loaded at this address to AX. So let's emulate and observe what happens. We say we run here, quad 1. Where is it coming from? It's coming from this memory location. As simple as that. Right. Addressing mode, direct addressing mode example. Right, here we're having this. We have data segment, we have code segment, and here we have defined a variable. We have declared a variable of size word, and we have given it a name, beta, and we've initialized it with 1234 h. Right, we now move the contents of beta into AX. We like this one. What we are having here is beta is a variable, and a variable is a memory location, right? So here beta, we are moving the contents at memory location of beta into AX, and the contents of memory location beta is 1234. So we are moving 1234, which are the contents of beta memory location. Beta is a memory location, beta is a value, is a variable. So we are moving 1234 into AX. Here it's just the same. Here we said move CX, move the contents of beta memory location into CX. So we are moving 1234 into CX. That's it. Right, here we have another instruction which is saying move the contents of memory location 2400h into DL. But do you have anything in 2400h? If we don't have anything, nothing is going to be inputted into DL, right? But if we have something, that something is going to be moved to DL. So here let's observe what is actually happening. Right, so we want to look at AX so that we observe what is actually happening. Right, this is the instruction, next instruction to be executed, and the address of it is shown in instruction pointer register. Instruction pointer, it points to the next instruction to be executed. Right, we run that, it's executed. We have 1 2 3 4. Now let's look at what is going to be executed. Let's run that. Right, let's check cx is 1 2 3 4, which is identical to that. So there's no difference in writing it this way or putting it that way. Anyway, let's emulate so that we observe what is happening with our DL. Do we have anything in DL? We don't have anything, meaning to say at this memory location there is nothing. But now let's put something. Let's try to put an address which is having something. Here we have org 100h, so let's put that 100h here. Since we said org 100, it's pointing to the first memory location where our code is going to be inserted or loaded in the memory. What we actually have is 100h as our first memory location. So the first line of our code is going to be loaded at this address. So let's get the hexadecimal value of our first line of code. Right, that and that. What we want to check is this line. So let's emulate. We have DL, which is that one. Let's emulate like that. So we have EB, thus this value is representing our first line of code in our program. This is wonderful. You can actually get an address of your code using your code. Like it's not going to save any changes. Right, let's see another example. Right, this is another example which is very simple. Right, we are moving the contents of memory location 0020 into AX. And what do we have? If we have nothing is going to be loaded. If we have something, it's going to be loaded into AX. Right, the value of AL is going to be loaded into that, right, that memory location like we did in the first example. Right, and the value at AL is going to be loaded to 1 2 3 4 offset of extra segment as specified by that instruction. So if we have these values here, we are having these values which are used to calculate the physical address. So assuming that our DS is 1000 and extra segment is that, right, we can calculate our physical address for this instruction by saying 2000 times 10 plus 1 2 3 4, which gives us what? I think it becomes 2234. That's it. Right, so let's observe what is happening. We actually do not have these values as actual values. We are just assuming as stated by that comment. So let's just run it so that we observe what is happening. So we just look at AX, nothing goes there because we don't have anything. There it's the memory. There we have extra segments. With this code, unfortunately, we don't have anything to view. Let's now look at this other example. This one, I like this one. This one is having SI. We are moving this value into source index register, right? So SI now contains 1 2 3 4. We've accessed our register and we've used it to store this value. Now we are using SI as the memory address or as the offset. So 1 2 1 3 is the value